We're going to stick with graphing systems of equations, except this time we're not going to necessarily look for where they intersect. We can graph systems of equations and then look for other parts. So, for example, here's number one. We want to graph the following equations. We're looking at these equations right here. And we need to always ask ourselves, what shape do these equations represent? Well, hopefully by now you realize that they are x squared and y squared, x squared and y squared. So we have ourselves two circles. But the problem is they're not in the form that we like. We like circles where we can pick out the center and the radius quickly. In other words, we like our circles to be in the form x minus h squared plus y minus k squared equals r squared. Well, we almost have it, but we have to complete the square. So we'll take this first example right here, and I'm going to set it up with my x's together. So I'm going to take the x squared, the minus 2x, then I'm going to leave some space and I'm going to do the y squared and the 4y, and then the minus 11 is going to go to the right side. I am trying to mimic that form. That's called center radius form, which we talked about in yesterday's video. So to get this into center radius form, we have to complete the square, which means I'm going to take half of negative 2, which is negative 1, square it, and add it to both sides. I'm going to take half of 4, square it, and add it to both sides. So there, I've completed the square. I can rewrite this as a binomial squared. In fact, it's x. Remember we took half of negative 2 to get negative 1. Over here, it was y. Half of 4 was positive 2. Let's see, that's 12 and 4 is 16. So there's our first circle. If we had to graph it, we know our center is 1, comma, negative 2, and our radius is 4. Okay, moving along, let's take the next equation and also set that to radius center form. X squared and the 4x get to go together. We'll complete the square with those two. Y squared and 2y get together over here. We'll take that negative 9 and we'll move it to the other side. Now I'll complete the square. Half of 4 is 2. Square it to get plus 4. What I do to the left side, I have to do to the right side. Y squared plus 2y. Half of the 2 is 1. 1 squared is 1. Add that there. If I rewrite this as a squared binomial, we know that it was 4, so we take half of 4, which is 2. We know this was the 2 that we took half of to square, so is 1. And then this ends up being 14. Well, that's not a pretty circle. Its center is pretty easy. We like its center. Its center is negative 2, negative 1. But the radius is an ugly number. It's the square root of 14. And that's why in this particular lesson, we're not going to find where they intersect. Because for us to graph it by hand, we really can't do the square root of 14 perfectly. Again, let's take a look at it on Desmos. Here it is on Desmos. I typed in the original problems. We have our center here of 1, negative 2, and 2, negative 1. And there's our blue circle and our red circle. I can touch where they intersect and see that it is really some ugly numbers. So if we did have to find their intersection, chances are we would do this in some kind of graphing utility. So if they're not going to ask us to graph it and find their intersection, what are they going to ask us to do? Well, first off, let's take a look at possibilities of what two circles can form. Here's some key phrases. Internally tangent. What the heck does internally tangent mean? It means this. It means one circle can be inside another circle, and tangent means to touch in one spot. You know how we say like, oh, let's get Mr. AB to go off on a tangent and talk about West Virginia. I know you're all laughing right now because you'll all try to do that. You probably expect me to go off tangent too by talking about the Mets or something. Externally tangent. All right, the circles are outside of each other and they touch at one spot. Two circles can intersect twice. And two circles can have no intersection. So think about how they can have no intersection. They can have no intersection outside, and they can have no intersection inside. So since today's lesson we're just looking at two circles, we just want to know all the possibilities of what two circles can do to each other. All right, so what are they going to have us do? Well, one thing they can have us do is find the distance between the centers of the circles. So here we have those same circles written in standard form. And actually, since we just graphed them on Desmos, give me a second. I'm going to get a screenshot of that picture. Okay, so here is a screenshot of that picture. And in this case, they want us to find the distance between the centers of the circle. So again, not that hard to do if you remember your stuff from geometry. Well, there's two ways to find distance of 2 points, or the distance of a line. You have the distance formula. And that is the square root of x1 minus x2 squared plus y1 minus y2 squared. So if you remember that from geometry and you like it, go for it. But I, for one, have never been a fan of the distance formula. I like Pythagorean's theorem. So what I do is I just create a little Pythagorean theorem triangle. So let's get a little line here. So what I do is I create a triangle. And I do Pythagorean's theorem. All right, the distance over here is a distance of -1 to 2 is a distance of 1. This distance along the bottom here is a distance of 1, 2, 3. So I'm going to do Pythagorean's theorem because that will give me the distance between the two centers. So the distance squared is 1 squared plus 3 squared. D squared equals 1 plus 9 is 10. So that distance between those two circles is the square root of 10. I can do the same thing with the distance formula if you don't believe me. Let's see, I've got to get my centers. So my center over here is 1, -2. And my center over here is -2, -1. So my x's, -2 minus 1 plus my y's are -1 minus a -2. Okay, and the opposites. So that is 1 squared. Hey, looks familiar. And that is -3 squared. Hey, looks familiar. 9 plus 1 all over a square root. And we get 10. All right, so this was just a little short lesson on some key points. 1, complete complete the square to find the center radius form of a circle. Don't mind my typing. We wanted you to review the distance formula. And we wanted to introduce the ways two circles can touch or not touch.